morning, my dear student. Today we will take the last two numbers of exercise 8.2 quadrilateral of class 9. That is number 6 and number 7. Number 6 question is so that the line segment joining the midpoints of the opposite side of a quadrilateral bisect each other. AB and CD are midpoints. Here P and R are the midpoint of AB and CD, and Q is the midpoint of BC and S is midpoint of AD. The line joining PR and SQ bisect each other. We have to prove this. So we have to prove that PR and SQ bisect each other. For this purpose, we need some construction, that is join PQ, QR, RS and SP. Let's make like this. And also we have to join AC. We have to make like this also. So construction join PQ, QR, RS and SP, and also AC. Now proof. We have to write in triangle DAC, we say that S is midpoint of AD. S is midpoint of AD and R is midpoint of CD, and R is midpoint of CD. So from midpoint theorem, SR must be parallel to AC. SR is parallel to AC and SR is half of AC. Similarly, in triangle BAC, P is midpoint of AB and Q is midpoint of BC. So we can write PQ is parallel to AC and PQ is half of AC. So similarly, in triangle ABC, we can write PQ is parallel to AC and PQ equal to half of AC. Let it equation 1 and this is be 2. From 1 and 2, SR is parallel to AC and PQ is parallel to AC. So we can write SR is parallel to PQ, and SR is half of AC, PQ is also half of AC, so SR is equal to PQ. See here, SR and PQ are the opposite side of a quadrilateral and both are equal and parallel. SR is parallel to PQ, SR equal to PQ. We know that if the two sides of a quadrilateral are equal and parallel, then it is a parallelogram. This implies that PQRS is a parallelogram. If PQRS is a parallelogram, then its diagonals are SQ and RP. So this implies that diagonals, which one? PR and SQ. Let's like this, PR and SQ, PR and SQ. What happened to its diagonal? In a parallelogram, diagonal bisect each other, so we can write diagonals PR and SQ bisect each other. So our number 7 is, it is given that in triangle ABC, angle C is 90 degree, M is midpoint of AB and MD is parallel to BC, or DM is parallel to CD. It is same thing. We have to prove that AD equal to CD, MD is perpendicular to AC, and CM and AM are equal and both are half of AB. We have to prove this. For this purpose, first we have to prove the first bit, that is AD and CD are equal. It is given that M is in triangle ABC, M is midpoint of AB and MD is parallel to BC. So by a converse of midpoint theorem, we can write D is midpoint of AC, that is AD is equal to CD. The first bit is proved. Second bit, if MD is parallel to BC, then angle D plus angle C is equal to 180 degree. It is given that angle C is 90 degree. So we can write angle D is also 180 minus 90 is equal to 90 degree. Third bit, in triangle AMD and CMD, in triangle AMD and triangle CMD, what are equal? AD equal to CD, AD is equal to CD, angle ADM is equal to angle CDM, and MD is common side, MD is equal to MD. So this implies that triangle AMD is congruent to triangle CMD. If two triangles are congruent, this is from SAS congruence rule. If two triangles are congruent, then their corresponding sides and corresponding angles are also equal. Hence, we can write AM is equal to CM, or this implies that AM equal to CM is equal to, M is midpoint of AB, so we can write AM is half of AB. So number 7 is also proved. Thank you.